Welcome back, folks. This is Daniel for Rock the JVM. This video is the second part of the mini bank project using Akka, Cats, and Cassandra, obviously in Scala. And if you didn't do so already, check out the first video in the mini-series where I talk about the architecture of the project and we write our first bank account persistent actor. And in this video, we are going to write the main bank actor, which will manage all of our bank accounts, and we're going to test the actor interaction. So get your code that you have at the end of the last video, and let's simply continue. Alright, now we would probably need to test this, but the persistent bank account will depend on a bank actor, so we will need to create that in order to be able to test this whole combination. So here under the actors package, I'm actually going to rename this to rockthejvm.bank. I'm going to call this as the application. And here on the actors package, I'm going to create another Scala class. I'm going to call this bank. And I'm going to make this bank actor a persistent actor as well, which means that I need to define some messages, that is commands. So we will need to define some commands that this bank can take. We need to define the events that the bank will persist to Cassandra and the state of this bank actor. Now, in terms of commands, I would like the bank actor to receive the same commands as the persistent bank account. So this bank actor will receive the commands, will serve as the entry point for all those commands, and upon reception of those commands, they will be forwarded to the appropriate persistent bank account actor. So I'll probably need to take away all of these commands and surface them out to the bank. So I'm going to define an object called command, and I'm going to put all these case classes inside. So I will place all the specific cases of command, and then I'm going to import everything. So I'm going to import command.everything. Or even better, I can take all of these definitions and place them in a companion object to persistent bank account. So I'm going to scroll all the way down. I'm going to create an object, persistent bank account, and I'm going to take all of those definitions and I'm going to put them in the companion object. So we have all these definitions here. Now import command underscore doesn't matter, but I will need to import all the definitions from the companion object. So persistent bank account everything. Cool. And I'm going to also import persistent bank account.command.everything. And this is important because if I don't do it, then the commands themselves will not be known to inside the persistent bank account class. And also I've isolated them inside the command object because I want to import them specifically under the bank actor. So here under bank, I'm going to import persistent bank account command everything. So I have access to all the commands of the persistent bank account here in this bank actor. Now, this organization may not be necessarily to your liking. Maybe you're interested in taking all those commands and putting them here under the bank actor instead of the persistent bank account, right? But I'll make do with this organization for now, at least. So we have all the commands here under the bank actor. As for events, I'm going to define a sealed trait. So sealed trait, I'm going to call this event, and I'm going to create a case class. And for bank, the only event that I really want to persist is that the bank account was created. So I'm going to have a case class for bank account created, which takes an ID as a string, and this extends event. So this is for the bank actor to keep track of all the creation of all the bank accounts. And the persistent bank account will also keep track of its own events. So we can keep track of separate events for both the bank actor and each persistent bank account in turn. Now, in terms of state, this bank actor will keep track of pretty much all the persistent bank accounts, and this will essentially be a map where the key is going to be the unique identifier of each persistent actor. So I'm going to create a case class. I'm going to call this state, and I'm going to store the accounts as a map of string and actor ref of command. Now, this command is the persistent bank account, so I'm going to import persistent bank account.command explicitly. So the trait command that I'm going to put here under the type signature of the actor ref. So I've defined all the commands which are imported, all the events, and the state. Now, because this bank actor is also a persistent actor, I will need to define it in terms of a message handler or command handler. Then we need an event handler, and finally the apply method to build the behavior. So I'm going to define each of these in turn. So the command handler is going to be, as it was the case with a persistent bank account, a function. So I'm going to have a val, let's call this command handler, and this will be a function from the state and the command, and this will return an effect that I'm going to have to import. So make sure you import the right one from the Scala DSL package. So an effect from of type event, which is this trait over here, and the same kind of state that we defined here in the function. So I'm going to have state here. I'm going to leave this unimplemented for now. So the command handler is a function that contains the actor's current state and the command that it has just received, and it produces an effect where the event type is denoted by the event trait here, and the same kind of state that we produced earlier. Cool. So we have the command handler as a signature at least. Then we have the event handler as a function from state and event, and this produces a new state. I'm going to leave this unimplemented as well. And the behavior itself is going to be an apply method. So I'm going to define an apply that is going to return a behavior of type command. And I'm going to leave it unimplemented because the apply method should be part of a companion object, but I've made the bank a class. I'm going to make it an object altogether because all these are just definitions, and the apply method will spin up the behavior of an actor. So I'm going to make it an object, which reminds me that the persistent bank account has a class and a companion object. That was a little bit of a mistake on my part. I'm going to take all these definitions, I'm going to bring them back, and I'm going to make this persistent bank account an object because we're in the same situation here as well. So I'm going to remove the companion, and I've just made the class an object with all the definitions here. So I don't need to import anything. I need to import just the command object with all the definitions so that I make them known inside this object. So a little bit of back and forth. So the persistent bank account is pretty much an object with all the same definitions, and the bank is also an object with an apply method that returns the behavior of the command. Cool. So in this case, I'm going to return, again, an event-sourced behavior. So this will be event-sourced behavior with the types command. This is the message that the bank actor will receive, the event that it will persist to Cassandra, and the state that it will manage internally. So I'm going to pass the persistence ID. So persistence ID as persistence ID, and I need to import that of unique ID, and I'm going to call this bank. I'm pretty sure this will be unique for our entire application. The empty state. So the empty state is going to be state with map exactly like this. Then we have the command handler equals command handler, and the event handler equals event handler. All right, so this is our event-sourced behavior. All right, cool. Now let's go implement our command handler and event handler. Now the command handler will need to be able to treat all these commands. Now, to remind us, we have create bank account, update balance, and get bank account. These will all be sent from the HTTP server. So the HTTP server will create all these data structures, and they will be sent to me, the bank actor, that will trigger the creation of bank accounts. So I'm going to run my little function, state and command, and then I need to return the effect. So I'm going to run a pattern match on command, some command match, and I'm going to treat all the cases. So in case we get a create bank account with user currency, initial balance, and the reply to actor, here I need to spin up a new child actor. So here I'm going to define a val as a unique identifier. I'm going to call this ID as UUID from Java util random UUID.toString. So this is a simple unique identifier, and I'm going to create a child actor, which is my new bank account. And I need the actor's context to be able to spin up the child actor, because I don't have the actor context here under either state or the command. So in Akka, we do context.spawn. Now, obviously, we don't have access to the actor context unless here in this behavior we obtain it somehow. So I'm going to wrap this event source behavior into a call to behaviors plural. Make sure you import the right one, .setup, which gives us this actor context. So the setup method will give us the actor context and then the behavior that we are going to return after that. So the context will now be provided to us. Now, this event sourced behavior will need to pass this context reference somehow. So the command handler will have to be, instead of a val, I'm going to make it a def, so a method that takes the context as the actor context. Actor context of command, which is the same type as the bank actor that I want to spin up. So the command handler will be invoked on the context. Right, so now we have access to the context because it was passed by behaviors.setup. So now I can spin up a child actor. So context.spawn, and then I'm going to use the behavior, which is my persistent bank account, applied to this unique identifier. So the persistent bank account has an apply method that returns a behavior. So the persistent bank account on ID, I'm going to use that ID also as the internal actor name in the actor system. Okay, so I've spun up my child actor. Now I need to return an effect. Now, after I've created this persistent bank account with this unique identifier, assuming that any user has the right to create as many accounts as they want, because it may be a cheap operation for us, I'm going to return an effect, and I'm going to persist. And I'm going to persist this bank account created event. So I'm going to say event.persist on this bank account created on this new ID. So the bank actor will store this event into Cassandra, and then I'm going to pass this create bank account message to the actor itself so that it can spin up its initial state. So I'm going to say then reply on the new bank account that was just created because this is an actor ref, and I will need to pass a lambda that uses this bank state, but I don't use it here. And I'm going to pass this same message, which is the same create bank account command. So I'm going to call this create command at. And notice that I'm not using anything user currency initial balance. I might simply replace these with underscores. Obviously, when you want to put some more logic here, you may want to check whether the user has the right to create an account. Maybe you want to charge them per account, or lots of logic that you want to create there. And I'm going to use this create command. So I'm passing this create command to the newly created persistent bank account. So once it's being created, then this whole command will get to it. And then once the bank account actor receives this create bank account, it will start its internal state and will also store its own event. All right. So this is what we want to do if we want to create a bank account in case we get what do we have here? Under command, we have an update balance on a particular amount. Cool. So I'm going to write an update balance here with all the right fields. So we have ID, currency, amount, and the reply to actor. And this reply to actor may be external to the bank, so I'm going to keep it at that. And I'm going to try to find the bank account associated to this ID. So I'm going to state dot accounts dot get on an ID, which notice that this is an option of the actor ref, which denotes this bank account. So I'm going to run another pattern match inside. You can also do this with flat maps if you want, but we're going to run different effects depending on the cases here. So in case we get a sum account, That means that we do have an account here. I'm going to send the same update balance to the bank account itself. I'm not going to do anything else. So I'm going to simply forward the update balance message to that account. So I'm going to say effect.reply to the bank account. So account. And I'm going to send this update balance message. So let's call this update command at update balance. And I don't need the currency amount reply to. Maybe we'll replace some of these parameters with underscores. We'll see. So I'm going to pass the same update command there. And in case I get a none, then I will need to reply to this reply to thing, which is an actor ref of responses. Now, responses are defined here under the persistent bank account. So the responses are bank account created a response, bank account balance updated response with an option. So I'm going to reply to the destination actor with a none here because the update message could not trigger an effect. So in case none, I'm going to say effect.reply to the reply to actor. So the final destination here. And I'm going to reply with a bank account. What was that? So I'm going to get back here. We have balance updated response. So I'm going to use this bank account balance updated response. And I might have to import it. I don't really like that. I'm going to treat imports shortly. So bank account balance updated response with a none because this is a failed account search. All right, cool. Now, let me treat the imports for a second. I'm going to go back to my persistent actor and I'm going to run an object here for response. And I'm going to put all the have some shortcut conflicts. Okay, so I'm going to put all the case classes inside, and I'm going to import response.everything. And here under the bank actor, I'm also going to import the response thing. So response. So that I have all the traits here. Okay, all the case classes. Cool. So that was for the update balance, and I don't need the currency, I don't need the amount, because the persistent bank account will treat the internal logic of updating its own balance. So as the bank actor, I'm simply forwarding this update command message to that particular bank account. Of course, you can complicate this logic as far as you want. Now, we need to have another case for, and we have a get bank account. So we have get bank account for an ID and reply to message, the reply to actor, and this is going to fetch the actor associated to this ID. So I'm going to say state.accounts get ID, and I'm going to run a pattern match again, and in case I get some with an account, I'm going to forward this message, the get bank account, there. So I'm going to say effect.reply to that account, and I'm going to pass this whole command. So get command at, I'm going to pass this to that particular bank account. So I'm going to say get CMD. And in case I get a none, then I'm going to pretty much reply with a very similar response here. So I'm going to say effect.reply to the destination message, which is the reply to actor, with a get bank account response containing a none, because this is a failed search. Cool, so this was the command handler for the bank actor. In case we want to create a bank account, I'm going to spin up a child actor, then I'm going to store an event, and then I'm going to forward that command to the child actor. And in case I get an update balance and a get bank account, I'm simply going to forward that message to the bank account if there is such a bank account. Otherwise, I'm going to reply with a none to whoever asks me for that. Okay, so that was the command handler. Let's treat the event handler. And in this case, the event handler is a little bit more simple in this case because we only have a single event to persist. So I'm going to run my two argument function, state and event. And I'm going to say event match. And in case we get a bank account created, on the ID. So this was the event that I'm storing in Cassandra. After it's being stored, I'm going to have to handle it. And then I'm going to update my internal state. Notice that I did not update my state here while I was creating the bank account. So I don't update the state here under the command handler. I only update state in the event handler. So I'm going to define my val bank account. So account. And here in this case, because we don't have the account in the state yet, we need to store it into the state. We need to find it by some other means. And thankfully, the Akka Actor system allows us to find a child actor based on its child name. So I need the actor context again. So I need to be able to pass it. So I'm going to use the context as the actor context of type command. And this is going to change to a method here, and I'm going to pass the actor context at the bottom. So now that I have access to the context, I can say context.child, and notice that you can find a child with or by a name, and this gives you back an option of an actor ref. So child of ID. Obviously, this is an option, so I need to be sure that it exists. And here we have a slightly more interesting problem, because when the command handler succeeds, then I'm pretty sure that it does exist because it's just being created by context.spawn here in the command handler. And after the bank account created is persisted, then the event handler will have to treat that. So the context.child ID surely exists. So exists after the command handler. So that's for sure. But in the case of recovery, the command handler doesn't work. Only the event handler replays all the events persisted in Cassandra. So all the events stored in Cassandra will be replayed here by the event handler, and at this point, context.child ID does not exist. So does not exist in the recovery mode. So I'll need to make sure that this a bank account needs to be created in recovery mode. So I'm going to simply call a get or else. And I'm going to spawn something. So I'm going to say context spawn, and I'm going to persistent bank account with that ID and with the child name ID. So this exists after the command handler. So I'm going to add the comment here, does not exist in the recovery mode, so needs to be created. So if the event handler operates while the actor is alive and the command handler worked, then the get or else simply returns the child actor that was created beforehand. But in recovery mode, I need to create it. So as Cassandra gives me back the bank account created on the ID, I need to be able to spawn it. And once the persistent bank account is respawned, then the persistent bank account will start replaying its own events. So that's the general gist here. There's a lot of magic happening at this particular phase. So I'm saying get or else, and this is of type actorref nothing. I need to type that as actorref command. So I'm going to say as instance of actorref command. Now, this as instance of is harmless because the actual bank account actor is of the appropriate type, either found here under context child or found under context.spawn. So it does have the actorref command type. I only need to make this known to the compiler as well. So this as instance of is harmless. And then I'm going to store this account into the state finally. So I'm going to return a new state. So state.copy, where we have the accounts as state.accounts plus the new association between ID and this account that I've either fetched from context.child or created in the case of recovery. All right, that was quite a big thing. And the behavior has been described, the event handler has just been completed, and the command handler was completed before. So we do have the bank account and the bank actors created. Let's run a small application so that we test these two. So let's call this bank playground. And here under the bank account application, I'm going to define a main method that will make this a runnable thing. And I'm going to define the root behavior of a potential actor system. I'm going to call this root behavior as a behavior. And I'm not going to particularly use the actor system to exchange messages to the root guardian itself. So I'm going to use not used in this case, which is a glorified unit or nothing in Akka. And I'm going to have behaviors.setup, and considering the actor context of the root actor system, I'm going to create a bank. I combined val with bank, and I got vank. Bank as context spawn, and I'm going to spawn a bank actor. So bank with the name bank. And I'm going to ask the bank account. So I'm going to use the ask pattern. I'm going to send a message, and I'm going to expect a future of the response. Here in this lambda, I'm going to say behavior is empty so that I can get rid of the compiler error. So I'm going to use the ask pattern, which you know from the Rock the JVM channel that I've explained before. So I'm going to say bank.ask. Now, in order to use the ask method, I need to import the ask pattern so that the ask method is available as an extension method. So here in the ask pattern, I'm going to import Akka Actor Typed, Scala DSL, and then ask pattern with a capital A, then everything, which will decorate this with the ask method. And you can place this at the top if you'd like. I'm going to keep this on screen so that you know what to import. So I'm going to have bank.ask, and we're going to pass a lambda that, given an intermediate actor, this is the reply to thing that I've specified earlier. So reply to arrow. So given an intermediate actor that Akka creates just for this one interaction, I'm going to run a create bank account. Now, I think I've imported that, which I don't particularly like. I'm going to import here. So I'm going to import persistent bank account everything, or persistent account command everything. So create bank account with some data, and we have user currency. Okay, so we have Daniel. Let's say we have currency USD, initial balance, let's say $10, and then the reply to actor, this is going to be the one, so reply to. And I need some implicits here, so we have a timeout and a scheduler, so I'm going to define those. So implicit val timeout as a timeout from Akka util. Going to define a timeout as 2 seconds, let's say. Of course, I need to import the seconds method. I'm going to go import Scala concurrent duration everything. I've done this more times than I can count. And we have the timeout here. Let me actually add the import for your convenience here on the screen so that you know what to expect. And also the scheduler. So I'm going to say implicit val scheduler, which is scheduler from Akka Actor Typed as context system scheduler. So this is how we obtain the scheduler capability of the actor system through the actor context. So we have bank.ask, and this is a future of a response. So this is going to be the future that contains the response that the bank will send back to this intermediate actor, which will then fulfill the future. This is quite convoluted for the ask pattern. So I'm going to run a flat map here. And in case I get a bank account create a response with an ID, I need to import the response also. So I'm going to run another import with response. So in case we get a bank account create response with an ID, I'm going to print something out. So I'm going to say context log info with, say, successfully created bank account, and I'm going to use this ID here. And then, considering the ID, I'm going to send another message to bank. I'm going to use the ask pattern again. So ask on another kind of lambda, so reply to arrow. And I'm going to try to obtain the bank account details. So I'm going to say get bank account with that ID, which we've obtained here. And I'm going to also use the reply to message, the reply to actor. And this will contain the future of the response of this interaction. So I'm going to run a for each here. I don't care about other interactions, and in case I get a get bank account response containing, we have what's that? We have an option of a bank account, so we have let's call this maybe bank account, and I'm just gonna print all the details. I'm gonna say context log info, and I'm going to have account details, and I'm going to inject this maybe bank account. And we need some implicits here. This is the execution context so that we can run the future transformations. So I'm going to run another implicit EC for execution context as context.execution context. This is just the thread pool for us to run the future. So this is the entire interaction. So I'm going to send the create bank account to the bank actor, and I'm expecting this to create the persistent bank account. And I'm going to expect this bank account create a response, and I'm going to print this details. And then I'm going to take this ID and ask the bank again. So another interaction. This is interaction number 2. And I'm going to expect again bank account response with the exact same bank details. Okay, that was quite a mouthful. Let's create the actor system. So system as actor system from Akka Actor Typed with this root behavior, and let's call this bank demo. Right. So probably after a couple of seconds, I'm going to shut down the actor system, but I'm going to terminate this from the console myself. And we're almost done, so this application is runnable, but in order to interact with Cassandra itself, we need to connect the Akka application to Cassandra. So we will need an application configuration. So here under source main Scala, under main, I'm going to create another directory. I'm going to call this resources, and the name is important because under source main resources, Akka will look for a particular file called application.conf. And here we're going to configure the details of the persistence journal. So we need 2 sets of configurations, one for the journal, which is the event store, and also for snapshots. And this is the snapshot store. And snapshots are another useful feature of Akka Persistence. Very useful in the case that you persist a lot of events, and replaying them would take a lot of time, which means that it's often the case that we need to store the exact state of the entire application in the database so that we can recover more easily, and this is the snapshot store, and we need to configure both for Cassandra to run. So the configuration are as follows. We have akka.persistence.journal.plugin. This is the plugin implementation, which in our case is akka.persistence, and notice that IntelliJ is quite handy here. So Akka Persistence.Cassandra.journal. And then we will need Akka Persistence Cassandra journal. This will be the root configuration that we're then going to use. And we're going to have to specify some configuration to automatically create the tables in the Cassandra database itself. So I'm going to say keyspace.autocreate equals true. And also going to use tables autocreate. So I'm going to have tables -autocreate equals true. So in the moment when we persist our first event, this will take a little bit longer for Cassandra to create the tables automatically. And we're also going to use a configuration from DataStax. So I'm going to say DataStax-Java driver, and I'm going to have advanced.reconnect on init. I have some notes here that I'm using for these configurations. I don't know off the top of my head, and that would have been a little crazy if I knew them off the top of my head. And we're going to store some equivalent configurations for the snapshot store. So we're going to have akka.persistence. And we have snapshot-store.plugin. And we're going to have Akka Persistence Cassandra snapshot instead of journal. So I'm going to copy this item here, and instead of journal, I'm going to say snapshot. And we're going to copy these 2 configurations, and instead of journal, we're going to say snapshot in both cases. So the configurations to auto-create the tables are true in this case as well. And also, I'm going to allow Java serialization because I do not have the space here to specify a custom serialization. I do this in a little course that I have called Akka serialization. So Akka actor.allow Java serialization equals on. I typed this myself, but you can find all of these configurations on the blog post, so you can copy and paste them into an application.com file stored under source main resources. So make sure the file path is identical as shown here. Cool. So with these configurations in place, the bank playground application, where is that? We have the bank playground application, which is an Akka application. We'll fetch that application.com file and we'll use the Cassandra journal to store some events. Now, we've written quite a bit of code and we haven't tested anything, so I hope I haven't missed something. Let's try to run this, making sure that your Docker container is active. All right, so make sure that this works. So I'm going to start the application. Fingers crossed. A couple of seconds for the compiler to run. Come on, compiler. Compile my massive code. All right. So we should be seeing some logs here. We have some logs, and we also have some logs in the Docker container as well. Hopefully, we have everything that we need. So we have quite a bunch of stuff. Reflective set accessible true. This is a red herring, so this is not necessarily a problem. Also here, this is good. Graph traversal. This is not that big of a deal. And we should, I'm gonna search for successfully. So successfully wrote queue, okay. Successfully wrote, successfully created. So nothing with the bank. Okay, recovery successful, handled, account, okay. So we have the replay of events because the bank actor is persistent. So we don't have anything to recover, neither for snapshots nor for events here. So this handled command, this is cool, resulting effect, persistent bank account created, this is great. So we have some message written to the Cassandra store. We're gonna check that out in just a second. So we have handled command, this is good. And using the Java serializer, okay, handled command, message to actor was not delivered. Okay, that's a problem. So we have the persistent bank account.response, bank account created response. This was not delivered. Why was that? I'm going to do a little bit of searching here. So it seems that the persistent bank account could not reply to this reply to actor. My hunch is that this reply to actor was intermediary and this turned into dead letters. So I'm going to attempt fixing that by replacing this reply to intermediate actor with an actual actor that can log things. So I'm going to write a full-fledged actor that can handle all these responses. Now, I'm interested at this phase whether the events were persisted in Cassandra. So I'm going to navigate back to my Docker container and I'm going to select star. So under CQL shell that you created earlier, I'm going to select star from a table that's called Akka.messages. Akka.messages is the table where all the events are going to be stored. And right now this should, first of all, succeed, and the messages table should not be empty. And all right, so it seems that we have some data here in Cassandra, and the bytes themselves are obviously serialized. So this is the actual data that's being stored. And we have the persistent ID. First of all, we have the persistent ID bank that stores probably the bank account created message. This is it. And then we have the persistence ID for the bank account. So this is the unique identifier for the bank account that was created. Now I killed my application and I'm going to drop everything. So I'm going to reset the state of the entire thing. So I'm going to say drop table akka.messages. Or not drop table, but I think truncate. So I'm going to say truncate akka.messages. So I'm going to clear the table. So right now we have the table header, but we don't have any data. That's good. And I'm going to go back and create a full-fledged reply to actor. So I'm going to say, let's call this response handler or something like that. And I'm going to use a context spawn. And I'm going to use behaviors.receive message of type response. And the response thing needs to be imported. So I'm going to import this as well. And I'm going to handle a partial function here. So in case I get this bank account created response, I'm going to say context log info. And in case I get the get bank account response, I'm going to say context log info, and I'm going to also return behaviors.same every time, because with every message I'm going to have to return a new behavior. In this case, I'm going to return the same behavior. And this thing will bear the name, let's call this reply handler or something. And instead of the ask pattern, I'm going to use the plain tell pattern. So I'm going to say bank tell create bank account on Daniel USD 10 and this response handler as the message. And also I'm going to send this get bank account. So I'm going to say bank tell get bank account on the ID. Now that ID has to be fetched from Cassandra, so I'm going to comment it for now, and I'm going to remove pretty much everything else in the meantime. So first, I'm going to send the create bank account message. I'm going to check Cassandra, then restart the application, and I'm going to expect that the get bank account will return some actual bank account details, which is a bigger test than we originally anticipated. So let's try running this one more time. All right, so we have a bunch of logs here, and we have unsupported access to actor context from the outside of actor. Okay, what am I going to do here? We have context.log. Well, I'm going to save that context.log. I'm going to call this logger as context.log. And instead of using context.log, I'm going to use the logger. So logger. And that will probably be it. Let's try to see if we have anything here in akka.messages. We do have something here in akka.messages, and the logger.info simply couldn't print anything. So the application did work, but the loggers did not. So I'm going to clear the table one more time. I'm going to run the application one more time. So let's try to run this. All right, so we have some info. We have successfully created bank account with this particular ID, and this should be consistent with what we find on Cassandra. So I'm going to copy this bank account ID, and I'm going to try to take a look at the messages table again. So DEDA. So this is the same bank account ID. This is great. I'm going to stop the application. I'm not going to remove anything from Cassandra. And upon restart, I expect that the bank actor will respawn the persistent bank account with the same ID, and that the bank account actor will have its own details. So I'm going to comment out the first create bank account. I'm going to uncomment the get bank account on this ID that I've just fetched, and this reply to actor will be the response handler. And if we have the account details here, then we have been successful. So we have the bank actor and also the bank account, which are both persistent. Fingers crossed. Let's see what happens. Okay, so we have account details with some. This is great. So we have bank account with the ID, Daniel, USD, and $10. So notice that the data was successfully fetched from Cassandra, even though the application was stopped. So Cassandra serves as our persistent store. Obviously, in this case, we don't have any further events, so these are the same two events. But as we create more bank accounts, we're going to see more events here under Cassandra. This is amazing. So we have the bank and bank account infrastructure already created for us, and this will surely scale with however many bank account actors we might want to create. All right, this is quite great. All right, so we have the actors. Now we need that HTTP interface. So we are going to use Akka HTTP to interact with the external world and fetch bank accounts, create bank accounts, and so on and so forth without me having to create dedicated applications to test this out. So here under the Scala folder, I'm going to create another package for HTTP. So I'm going to create a package rock the JVM bank, and then I'm going to use HTTP. And notice that IntelliJ has created this underlying HTTP package here. And I'm going to create an HTTP server that will spin up pretty much everything that we've discussed. But that will be a subject for the next video, so thank you for following along so far. All right, so at this point, we have a fully functional actor interaction, so the core of the application is more or less complete. So join me in the next video where we are going to create the REST API to interact with this application. So if you like this video, give me a thumbs up and subscribe because the next video is coming right up.